Okay, so this is homework 7, problem number 5. And so we're given that x is a discrete random variable represented by two impulses with height 0.5 each at 0 and 1. And y is just given by the step function with height 1 and it stops at 1. And so we know that x and y are independent, and we want to find z is equal to x plus y, and we want to find and draw small f of z. And so since x and y are independent, then small f of z is just a convolution between small f of x of z and small f of y of z. And so there are two ways to do this problem. We can use the time domain, and so we can represent this graph as 0.5 times the impulse at z, and 0.5 plus 0.5 times the impulse of z minus 1, which will represent this impulse here, shifted over to the right by 1. And this step function can be represented by the unit step at 0 minus the unit step shifted over by 1, so z minus 1. And so when you do a convolution in the time domain, it ends up just being a product of the two functions. And so you just simply fold it out. So 0.5 times the impulse times the unit step just becomes 0.5 times the unit step, because the impulse has no width and infinite height, so it's effectively just 0.5 in terms of area. So when you multiply that by the unit step function, it just becomes a unit step function with the height of the impulse. And then the inside would just be 0.5 times, since the impulse is shifted over by 1, that shift carries over when you multiply it by the step function. So it's 0.5 times the step function of z minus 1. And then when you do the outside, it becomes 0.5 impulse times the negative unit step function of z minus 1. And so similarly, the shift carries over when you multiply it. So it becomes negative 0.5 step function of z minus 1. And then finally, it's 0.5 of the impulse shifted by 1 times unit step function shifted by 1. So the shifts are added up, so it becomes 0.5 of the unit step function shifted by 2 to the right. And so the middle terms cancel out, and you get 0.5 of the unit step function at z minus unit step function of z minus 2, which is simply just the unit step function from 0 to 2 with height 0.5, and that is what every f of z looks like. You can also do this in the Laplace domain, and so similarly with in the time domain, when you're multiplying two Laplace functions, convoluting two ends up just being multiplying the product of the two, multiplying the two. And so f of x, the two impulses, can be represented by 0.5, because the constant in the Laplace transform ends up just being that constant. And then the shift in the Laplace transform can be represented by e to the negative s. So if it's e to the negative s because it's shifted to the right by 1. If it was shifted to the left by 1, it will simply just be e to the s. And then times the unit step function at 0, which is the Laplace transform of the unit step function at 0 is just equal to 1 over s, minus the unit step function, so 1 over s, times the shift, which is over to the right by 1, so it's e to the negative s. So similarly, we also FOIL that out. So the first two terms be 0.5 over divided by s, middle terms be 0.5 e to the s divided by s, outer terms becomes negative 0.5 e to the negative s over s, so these terms will cancel out, minus 0.5 e to the negative 2, because e to the negative 2 s because the two exponentials end up adding up divided by s, so minus. So this middle term cancels out, so it's 0.5 1 over s minus e to the negative 2 over s. And so we just know 1 over s is just equal to the unit step function in the time domain. E to the negative 2 over s is equal to the unit step function shifted over by 2 to the right. So we have the same answer. And so you can choose whichever version is easier for you to understand. And that is it.